Hi, I'm Milad, and in this video I want to introduce a project I completed titled Analysis and Validation of a Composite Pressure Vessel for Liquefied Ammonia Storage. This project was designed to evaluate the performance of composite tanks for storing liquid ammonia, which plays a significant role in transportation and alternative energy sectors. I'm a PhD student in mechanical engineering, specializing in solid mechanics, conducting research on the application of artificial intelligence algorithms in mechanical engineering. I have over 18 years of experience working in various industries, and more than 15 years of teaching Abaqus software in collaboration with different institutions and universities. In addition to introductory and advanced Abaqus courses, I've taught specialized workshops on the design and analysis of composite structures in Abaqus, vibration analysis, and subroutine programming. The main objective of this research was the numerical analysis of a pressure vessel using the finite element method, and validation of the results with reference article data. In this part, you can see the article in question, which was published in 2020. I recommend that before purchasing the product, in addition to watching this video, you also read the article. In this study, two types of composite materials for the vessel body, CFRP and GFRP, and two types of polymers for the inner liner, PP and PET, were examined. The analyses were conducted under both static and dynamic impact conditions to evaluate the vessel's behavior under different loading scenarios. In the prepared report, the article is first reviewed, followed by a detailed modeling process. The geometric modeling of the vessel was done in SolidWorks, and then simulated in the Abaqus environment. For the composite body, S4R elements were used, and for the liner, C3D8R elements were applied. The liner thickness was divided into 5 elements along the thickness direction to improve the accuracy of the analysis. For validation, the results of von Mises stress, fiber tensile failure criterion, and matrix tensile failure criterion were compared with the data from the reference article. The comparison charts between the FEM model and the article show acceptable agreement. For example, the max von Mises stress chart in the liner for the GFRP PET material at different layup angles is shown, which demonstrates good overlap with the article. This process was carried out for all layup configurations. Additionally, in the dynamic case, 2 layup samples were selected and validated. This research shows that using composite materials in the design of pressure vessels for storing liquid ammonia offers significant advantages in terms of both weight and mechanical strength. The results of this project can be applied to the design of fuel tanks for transportation vehicles, petrochemical industries, and energy storage systems. Thank you for staying with me until the end of this video. In this package, you will receive the Abaqus file with the CAE extension, along with the 3D model created in SolidWorks. Additionally, a detailed and comprehensive report of the modeling steps, prepared as a tutorial along with the validation results, will be provided. If you're looking for practical, precise, and well-documented learning in the field of composite pressure vessel analysis, this training can help guide your path. To register and download the files, please visit the Engineering Downloads website using the link below.